Welcome. I'm Bob Schremp. I'm here today at the Central Valley Model Works shops. I'm with Chad Stallsworth, Tim Reynolds, Jeff Parker, and Harry Shada. And we're going to be talking about the MSS Bus module signal system. And we're going to talk about how to take an existing module, which we've got here. It's got a single track, nothing on it, no switches, no turnouts, just a single track module, and how to add the signaling bus to this, which gives you your current detection, so this can be used with other modules that have signals on them, and those signals will react to this module. We know there's been a lot of confusion and misconception, and people don't always understand exactly what it is, and we're going to show you how simple it is to take this module and make it fit the standard and be MSS ready to work with other modules that have signals. What is the module signaling standard, the MSS standard? Right now, most of Fremo is using MSS, and that standard is got three different components to it. One of them is the signal component, one of them is the detection component, and the other one is the transportation layer that takes detection information and sends it to the signals so the signals react properly. We're not going to be talking about signals today because signals are very advanced, they're more expensive. The bus is pretty much standardized, so we're going to be talking about a little bit about the bus and this module, how to add the current detection so that it works with all those others. One of the things you need to know, the way that this works is you take a bunch of modules, they're all set up the same, and you have signals on one module, and we call that a cascade. We have signals on another module, and that's a cascade, and all the modules in between hook together and work as one block between those two signals, so that those signals on either end react to what's happening on the modules in between. And we're going to show you how to set this module up to do that. So before we talk about actually how to wire this module, we're going to talk about some of the different kinds of cables we use, because you'll hear crossover cable, straight through cable. We have one we call a flip cable. What's the difference between all those cables? So I've got some cable here, and we're going to look at a piece of flat ribbon cable because it makes it really easy to see. The same information applies to the throttle cables that you make to go between your throttle jacks for the Digitrax. First cable, you'll notice it's a flat ribbon cable, and this is very easy to see that those two connectors are put on with the little tab on the same side and the connections on the same side, the wire connections. If you were to take this and fold it in half and look at it and look at the wires, we'll get some close-up pictures of that we'll add in. The two of them are opposite. This is what we would call a flip cable. This is a bad cable. This never should be wired this way. This is wrong. This, when you look at it, tabs are up on this end, one tab's down versus up. That's the correct cable. One's up, one's down. When you put the two ends together and look at them the same, the wiring colors are identical and they're in the same order, meaning that pin 1 went to pin 1. This one, pin 1 went to pin 8. So those are your two basic cables when you're using flat ribbon cable. Your standard straight through cable, and what we call a flip cable. This is a bad cable. Flip is bad. We'll show you a wiring diagram. I don't have these in a flat ribbon cable, but the next one is an Ethernet crossover cable. You need to know that an Ethernet crossover cables are not all the same. People have started selling 1 gigabit crossover cables, and I'll tell you what's different about those. Those don't work. But the MSS bus works off of Ethernet cables. Let's go over here and talk about the difference of those cables. The cable we use in the MSS is a crossover cable, so I'm doing it first. You'll notice that pins 1 and 2 go to pins 3 and 6, pins 3 and 6 go to pins 1 and 2. Those two data things cross that data information, and they cross. This is the correct wiring diagram. Some that you'll see will have 4 and 5 crossed with 7 and 8. That's a 1 gigabit crossover. Bad. We don't want those. Those are not what we want to use. We want to use the standard crossover cable. The next one we talked about was the straight through cable. That's the other good cable. There are places we'll use that. We'll talk about sometimes you could use a straight through cable here. And you'll notice 1 to 1, 2 to 2, 3 to 3, all the way down to 8 to 8. The flip cable, this is a messy looking diagram, but this is what it's doing. You'll see they're crossing. This right hand side shows you 1 to 8, 2 to 7, 1 to 8 to 1. It's flipping. That's not a good cable, never a good cable. Don't use this one anywhere. You should always have them do the right way. So how do you tell the difference? Again, if you take the two ends and you hold them up side by side so they're looking at them the same, you can look at the colors of the wires and tell whether they're done right. You can also use something like this. This happens to be a Klein Tools product. I got this at Home Depot. I love this connector. The bottom comes off, so I can put this at one end of a cable and this at the other end of a cable. So if we take this straight through correct cable and I plug it in here, and I plug it in here, and we turn this on, and I hit the data button. I don't know if you can see that, but you'll see that it shows pins 1 to 1 to 2 to 2 to 3 to 3, all the way to 8 to 8, and it's 1 to 1. Now if we take that cable out, and we put in the one that's wrong, the two tabs are on the same side, we put the same cable in here, and if you look at this, you'll see that it's flashing and doing stuff. 1 goes to 8 and blah, 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 and 8 goes to 1 because that's a flip cable. That's a bad cable. That's not the cable we want to use. I'm going to take that off. This one happens to be an Ethernet crossover cable. I'm going to plug it in here. Maybe. And you'll notice that it comes up, it says pass, and it's flashing crossover. And when you look in there, you'll see that 3 is going to 6, and 6 is going to 3, 4 to 4, 5 to 5, 7 and 8 go to 7 and 8. It's showing you that it's a crossover cable. I don't know if you can see that in the picture. Now, that's your basic stuff. The next thing, I've got a couple of straight through cables here. And these are straight through cables. And I will just throw it on the tester just to make sure, because there's nothing like testing to make sure. And I'm looking at that, and that's a straight through cable. I'm going to take that cable off. I'm going to stick this cable on. And there's a reason I'm doing this, and I'll explain it in a moment. And this is a straight through cable. So these two blue cables are straight through cables. The next thing is connectors that are female to female connectors. We use these all the time. Some of these are flip connectors, some of them are straight through. You need to make sure when you're buying them, you're getting straight through connectors, not flip connectors. And the way that we can test that is we can take and we can hook it up with two known good cables. That's why we tested them. And then I look at that and I come through straight through, 1 to 1, 8 to 8, good. This is a straight through connector and I know it, I've tested it. I can tell you I've tested this one also. So we want to make sure they're straight. If this had been a flip connector, it would have been 1 to 8 and down to 8 to 1, messing up us. We want to make sure that we're using all straight through connectors, and we're going to use only crossover connectors when we're doing most of our stuff on the MSS bus. A crossover cable is a little bit more. When we talk about the MSS bus, you'll always hear people say you have to have an odd number of crossover cables, an odd number. Why do you need an odd number of crossover cables? So I've got a crossover cable hooked into here. I'm just going to hook it up. I realize you guys can't see this screen very well, but somewhat it's for myself. And it comes up, and it's coming up and telling me that it's a crossover cable. So now, if I take that crossover cable out, and I put another crossover cable here, and I hook it up, and this is a feature of crossover cables, and we're exploiting this feature. It now says that it's a straight through cable because two crossovers in a row turn into a straight through cable. If we add another crossover cable in here, so we go to a third one, and hook up a third crossover cable, and now it comes back and it tells me I've got a crossover cable again. So it's very important that we have an odd number of crossover cables because the MSS bus expects you to have a crossover from one end to the other end of your module. So it's one crossover or an odd number from end to end. Harry has a question.
Two questions. One, that the crossover, odd crossover, is within each module.
That is
for
correct.
Current detection. And then the second question is, on your little female to females, are those flips or straight throughs?
They're straight throughs. We talked
Okay.
about that
Yeah,
earlier.
I know.
We tested
Yeah,
them.
yeah,
Yep.
yeah. Okay. Just
So
wanted to
I'm
have a
making sure
question.
that it's a good question. I'm always making sure that I'm only using straight through female-female connectors. If I ever have one that's a flip, I throw it away. I don't want it in my toolbox.
The question is, why do we do this?
Yeah. So the crossover the way that the system works by crossing over, it's when I look at it from this end, the local track is on a certain pin, and the next two modules down the line are on two other pins when I'm looking at my detection. When I look from this end, I want that same thing to happen going the other direction. So that crossover takes and makes sure that looking this direction, I'm always seeing a mirror image of what I'm seeing in that direction, and that crossover is making sure that that happens so that I'm seeing things flip that way, because what was advanced that way needs to be a different spot here. It's confusing, and I don't want to go into all the details, but trust us that that's what has to happen.
The simple answer is it's because that's what lets us turn modules around in free.
Okay, that's what makes it, yes, that's what makes the modules reversible.
They're all mirrored.
Yes, by having an odd number of crossovers makes the module reversible. So as Harry was asking, you want to have some kind of a connector that you're going to hook onto on this end, and to the other end of the module, it's a crossover, an odd number. It can be 1, it can be 3, it can be 5, it cannot be 2, it cannot be 4. An odd number of crossovers. Now, just to try not to be confusing, but to add just a little bit to the mix, if I have a single crossover and my straight through connector and a straight through cable, and I hook it up, that equals a crossover, because there's one crossover in there, and a straight through cable is still a crossover. So it's important that you know your crossover cables from your straight through, and that's how we talked about that there's times when you can use a combination of them. Well, it depends on what you're doing, but you have to have an odd number of crossovers from end to end so that your entire module looks like a crossover from one end to the other end. So the next thing we're going to do, we're going to start and actually talk about what components does it take and how do we make this module have the MSS bus in it. So you can see over here, Harry, let's roll this up so they can see it. This is a simple single track module, one track, end to end, nothing fancy, no turnouts, no anything. And this is probably the simplest module there is, so we're trying to start with a very simple module. We're going to put this back up on its side, and Harry's going to clamp it back on the table so we don't drop it. And Chad, you were going to do us a little drawing of what's going on in this module.
Hi, I'm Chad Stallsworth from Primo SLO. We're going to talk a little bit today about the way that existing modules have MSS, that don't have MSS installed, how they are today, and what changes we need to make in order to implement the MSS bus and current detection on an existing module, or on a new module for that matter. Today, most of us have a layout of our wiring on our modules very similar to this. This is a single track module. We have the power pole connections bringing power into a track bus that runs across the module and feeds out to the next module through the next set of power pole connectors. We have an accessory bus that runs straight across the module. We may tap off of it or we may not, depending on what we have on our module. And then we have the booster common that runs straight across the module with no ins, no outs, just the booster common wire. In order to implement MSS, we need to do two things. We need to add a second power bus that goes all the way end to end so that we can isolate the power that we're trying to detect, the current that we're trying to detect from the normal flow, and we're also going to have to add an MSS signaling bus. In order to add the power bus, we basically isolate the bus on the current module by cutting both ends. We take the power pole modules and move those connections to the new bus that runs end to end on the module. So now we have the
Uninterrupted.
Go ahead. Uninterrupted system power that runs from one end to the other end, and we have this isolated bus. We will now take the BD20, which is the current detection module, and we will insert that in one lead of the track bus, of the old track bus and connect it to the new feed. The other lead will connect down here to the other bus. Now we now have the module configured for current detection because all of the current flow for the track on this module will flow through this wire and we'll be able to detect how much current's being drawn on this module. The second half of this is we need to add the MSS bus,
And remember, that's an odd number of crossovers from end to end.
right? Odd number of crossovers from end to end, and the MSS bus will take the output of the BD20 or whatever current detector you're using and connect it to the MSS bus.
Couple questions. You only detect one rail of a single track.
Yes,
Okay. Do you, if it was a double track, you would do another rail on the other track?
and a double
Could
track,
you do the same side rail, meaning if you're doing left rail for
doesn't
detection?
really matter.
Does it? Okay, that's
Okay, with the double track, there would be a second track here with this detection bus, but they could both be fed off of the same power bus.
So what we would do is we would duplicate everything from here up. You
Yeah.
duplicate the track, you duplicate the feeder, the isolated feeder, you duplicate the BD20, you duplicate a second MSS bus because it takes one MSS bus per track.
Do you do you current detect sidings,
No.
No,
So
just main lines or through tracks?
just mainline and through tracks. Also, sometimes a question comes up, why don't I just put my BD20 right here? A BD20 or your current detector, it's like a flow detector, think of it like a water meter. It's measuring when something's using electricity, and it's gonna let you know that it's being used. If we were to put it in the main bus, it's going from end to end, the next module down the line, if the booster was on this end, it would detect something on this track, and it would detect something when it's down there, and something when it's down there, and we're not gonna get what we want. We wanna only know when something's on this piece of track, on this module. So we have to have this, what I call local bus or isolated bus, and we're detecting just that track. If you have a siding like Harry was talking about, let's just draw a quick little siding in here. We have a siding. We're going to double insulate right here, and then we're going to power these tracks off of the main bus because we don't want to detect them. We don't want to see when they're flowing. Like I said, it's like a flow meter. How does the electricity get there? It comes down this wire, it comes through the BD20 and then into this track and up to this track. On this track, it's going to come through the power pole and go straight up here, never go through the BD20, so we don't detect that. Now, there's some other things you do in the MSS that we're not going to get into with a siding because we want to talk about just a simple module. But if you have a siding, you need to isolate it and tie it directly to your power bus, not the local bus that's going through your BD20. So I'm just going to take this off of here because the module we're demonstrating does not have a siding today.
And so most modules in existence right now that have been built in the past have the local bus with feeders to the track. That's what we're calling the local
This
bus.
bus.
Yeah, the
Yes.
local
Yeah,
bus.
okay,
And we
great.
want to take that bus and we want to isolate it and put in
A new straight through bus that connects module power to module power to module power, and they remain undetected.
correct.
correct.
So we just talked about that we add another bus. So what we like to use here in Fremont Slow is this. It's 14 gauge. You can get it at most hardware stores. It's called trailer wire usually. It's 4 wires and a ribbon cable, 14 gauge, so it meets our spec. We're going to run a piece of this from end to end, and this is going to become our new bus for both the accessory bus and the track bus. And then we're going to take all the local stuff and make it local, and the detected local isolated bus will be the one that's existing in there. So we're going to add this in here, we're going to go offline, we're going to add it, and then we'll come back and show you what it looks like. Okay, so we've got the module here. It's already wired existing. This is before we started. So we're going to take and we're going to, like I talked about, we're going to add our ribbon cable. What we've got right now is we've got a green and yellow. This is our accessory bus. It's running from end to end. We've got our existing track bus running from end to end. This purple is our booster common running from end to end. what we're going to do is we're going to actually take out this green and yellow wire, and we're going to replace it with the green and yellow on this. And then we're going to also have the brown and white. And the brown and white is going to become our new track bus. And then we're going to jumper from the brown and white into the existing track bus, and that's where we're going to put our BD20 to detect current between this new bus and the existing bus. We talked about that over there in the drawing. So this is what it looks like right now. We'll be back in a minute after we've done some work and show you what it looks like. We've added the new bus wire from end to end. We took out the accessory bus that was in there because we replaced it. We didn't have to. We did that just because we're using this fancy wire. Now, one of the advantages of using the wire like this, and we go from end to end, is we don't break it anywhere, and we're going to do our connections off of the screw terminals on this end. What that does for us is if we had accessories in here, we'd power them off of one of the terminals on one end or the other, or both. If there was a problem on the accessory bus, we could disconnect this module and isolate it by taking those wires off, and this wire would still run the power from end to end. Where if you cut into the middle and tap into this wire, you have no way to isolate your module. So that's one of the reasons I like to use a piece of this ribbon cable and go from end to end. It gives me a good solid wiring from end to end, no taps, no T's. If I need to isolate the module, I can. Now, we didn't take out the old red and white. The red and white in here is going to the track. So the next thing we're going to do is we're going to add our BD20. We're going to take the BD20, and this wire is isolated right now. You can't really see, but there's no connection on either end. It comes down and it's screwed on, but nothing's connected to it. So on one end, or in one place, it's very important, in one place, we will add wires from the pigtails up to this local track bus, the detected bus, and one of those will go through this BD20. We will not do it on both ends. We will only do it in one place. You could do it in the middle of the module. You could do it on one end of the module. One place and one place only. Connect the track bus, which is coming in on the red and white here, going on to the brown and white in the ribbon, going out the brown and white to the red and white on the other end, to the other pigtail. So we have that pigtail to pigtail uninterrupted, and we'll jumper on this one of these across and into the track bus. Okay, so we've now added at this end our BD20. You'll notice that it's connected between the pigtail, which is connected to the bus wires, and the localized isolated bus that's our detection bus. And it's one wire goes through the BD20. You need to be careful. A lot of people want to use a smaller wire and wrap it around a BD20 3 or 4 or 5 times. The problem is that these, I forget if it's 100 to 1 or 500 to 1, but every time you wrap it, it increases the power. And so when you wrap it 2 or 3 times, that's how you blow out components, and why people are having some problems with some of these things and the board's blowing up, because they wrap them 2 or 3 times and they get a high spike because it multiplies by every time you wrap it. So if this was 100 to 1, and you go through 1, for every 1 you get 100 on the other side, or vice versa. I forget which way this is working.
I don't remember.
And if you double it though, then all of a sudden you're going to get 50 to 1, and if you triple it, it's 33, and if you go 4 times, it's 25 to 1. And so you're
What gauge wire are you using today?
We're using 14 gauge
Okay.
wire. We're used that same wire.
And
We
then
actually use the exact same wire we used for this bus.
And that gets you one wrap.
And that gets us one wrap. Now at this end, you'll notice we didn't put anything on the detection bus. It's sitting here by itself, not connected to anything, because like we said, we only want to connect in one location between the track bus and the local detected bus. So that's all the big wiring we need to do. Now we need to actually put in the crossover connections and that. And there's a couple of different options on that. We're going to go talk about a whole bunch of options and different ways you can do that. Some components from a couple of different vendors, stuff off the shelf, stuff you can buy from some other people to make it easier. There's ways to make it plug and play and ways to do a little bit of work yourself. And we'll talk about all those different options that we can think of and show you how you can do that. And then we'll do one of them to this module. Just a little note I want to talk about. If you're using non-insulated crimping connectors, spade connectors, and crimp them with pliers like this, a lot of mistakes people make. There's a bumped outside and a small inside, and on this connector there's a slot, a split on one side. The split side, which is should go to the round side, so you're pushing in the back. You shouldn't be pushing in the side that's got the split in it. You should be pushing in from the other side when you do a crimp like this. If you do it the other way around, they don't hold very well. They're not very strong. And we're going to put some wire ties in here to neaten stuff up. I want to just mention that instead of going around a wire once like that with a wire tie, you should go all the way around and then come back in so that you have a full loop around your wires. That makes your wire tie hold a lot better. If you do a single loop, your wires will slip through that wire tie real easy. If you do a full loop like that and then tie it, your wires are going to be held much tighter and they won't move around as easily.
And I want to mention one more thing. In this case, we used a BD20. There are other products that you can use. We like BD20s. We use them for a couple of reasons. Most of the other products need to have power, and the BD20 doesn't need to be powered if all you want to do is just a current detection. So I just want to mention that there are other products, but we're just happen to be using the BD20 for this particular install.
And the BD20 comes from NCE.
Yes, it's an NCE BD20. It is DCC only, and there are some other guys out there that are doing some combination stuff, and so they're using a different current detector because it'll detect both DC and DCC. But there's lots of products on the market, and really doesn't matter which one you're using. We've got the wiring set for all the track bus, and now we need to actually add the signal bus. The most simplest of ways is probably a crossover cable. You can buy this from the store. This one is long enough to do this module. And 2 straight through connectors. And so you're going to have one connector on each end. And then I like to take my wire and I'll do a service loop in the middle like this and put a wire tie on it. Then you break out and take the insulation off. You break out the blue, white, and the blue wires, and you take the white ones, you keep them hooked together, you keep the blue ones hooked together, and those hooked to your BD20. The white is the ground, and the blue is the logic. And that's all it takes, and this module will be finished. That's one way. The next step up is to just take a piece of wire, and you can take a piece of wire like this, and you can buy connectors that go, people use these all the time to hook up networking in their house. There's all kinds of different face plates you can get. You can get single, double, triples. You can get little boxes like this that hold those that mount on there. This mounts inside that box. And when you look at the side of this, it tells you how to wire it. There's 2 sets on here. Can you zoom in on this, Tim? And you'll notice that there's 2 sets of colors above and below and above and below. And there's a little A and a B and an A and a B. One end is A and one end is B. Remember when we looked at the wiring that we did up on the whiteboard, the crossover had pins 2 and 3, or 3 and 6 crossed with 3 and 6. And so if you look at this, if you use the top, that's going to be an A. That's orange and white, so you're going to put the orange wire here and the orange-white wire there, brown and brown-white. On the other side, again using the top, we're going to use white and green and white and blue. On the other end of the module, you'll do it the other way, so this would be white and orange and white and blue, and on this side will be green and white and brown and white. So that's going to, you can see right there how on one's A and B, the green and whites are green and orange, and the green and orange swap positions. If you do one as an A and one as a B, you have a crossover. If you do 2 A's, you have a straight through. If you do 2 B's, you have a crossover or a straight through. So 2 A's, 2 B's, straight through, crossover is 1 A, 1 B. So I know that's I'm tongue-tying myself. So we take a piece of the networking cable, we stretch it out, we do an A on one side, a B on the other side. We've got a crossover cable. We break the wires out in the middle. We're good to go, and we're done. So that's the next level up. The next step up from that is you can buy something from, this is one from Scale Signal Systems. And they've got little connectors like this and this. I'm getting a couple of them out here. They're not all the same. but they're all similar. Now, this is an MSS crossover. It says so right on it. It says crossover. This one says MSS crossover. This one's designed to do a double track module. MSS crossover. The difference between these two is the type of connector. You've got a screw terminal, or you've got a little wire. You got some of those wires that go on there, Chad?
Yeah.
They also make this other one that's a straight through. This one, it's got an X on it. It's a crossover. Again, they've got them with the little connectors or screw terminals. Now with these crossovers, we want an odd number of crossovers. So that means we would use 2 crossover cables. These are crossover cables. I'd have a crossover cable. One of these, it's a crossover cable, and 2 of the straight through connectors. And we're going to have our setup. No wires to cut, no wires to strip, strictly plug and play, straight up.
Bob, odd number of crossovers. So the little device you're holding is in itself a crossover functioning.
Yes, this is a crossover. It's got an X and it says MSS crossover on it. So it is from one end to the other crossover. We hooked up our connector to
It's
this.
essentially a piece of cable.
It's essentially a piece of cable with the blue and white wire broken out so you don't have to strip any wires. And that's the next level up. Was there another level above this, Chad? So that's the levels. You could mix and match. If you know what you're doing, you could use a piece of cable on one side of this and these kind of connectors at the end so you can put these boxes on the end rather than using these.
There's a lot of options.
There's a lot of options. They also make some of these that are straight through. This is the equivalent of this connector. They're the same thing. This one though has holes in it so you can take and screw it and mount it onto your module, which is really nice. Where this one you've got to use a piece of tape or a piece of Velcro. And these cost, I don't know, $3 or $4, $5 or $6 a piece. So they're not cheap. These are much cheaper, but these you've got to like glue them on or Velcro them on. These ones have holes so you can screw them on. So it's a straight through. This is a straight through connector. So I would have a straight through connector to a crossover cable, to a crossover connector, to a crossover cable, to a straight through connector. I'm going to put one of these other ones on the other end just because they're equivalent. And so I've got a straight through. I've got 1, 2, 3 crossovers. My odd number of crossovers is straight through and a straight through. This one would get glued or taped or Velcroed. This one has holes and gets screwed on. And then
You can also use that crossover in 2 straight cables.
you can also, that's great, thank you. You can also use this crossover and 2 straight cables because that would give me an odd number because that'd be straight is no crossovers, a crossover connector, straight, which is no crossovers, so that gives me 1 crossover, which is an odd number. You could also use 3 of these and a straight cable. I mean, it just becomes endless. The point is that you got to count those types of crossovers. This says on it crossover. This one does not. This one says MSS straight. This one says MSS crossover. It says it on them. So you can't mix them up. Well, I shouldn't say can't because someone's going to. You shouldn't be able to mix them up. But you could use a crossover, a crossover, a crossover, and 2 straight cables. You could use a crossover, 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 and use 3 of these and 2 crossover cables, and that's an odd number because that's going to give you 5. It's odd, odd, odd. We're in Fremo. We like trains. We're odd. The MSS is odd. They go together, odd and odd.
So Bob, again, where can I purchase those boards?
You can get these from Scale Signal Systems. Google them. Scale Signal Systems. www.modularscalesignals.com.
That's the old one.
Oh, that's the old one.
ScaleSignalSystems.com.
ScaleSignalSystems.com.
Yep.
ScaleSignalSystems.com. Probably on one of these. There it is. ScaleSignalSystems.com. Scale Signal Systems. There's a number of vendors that make these same things. I know Barry Draper's making them down in LA, and he sells them. Who are the guys up in Canada?
God, I forgot the name.
Iowa scale.
Iowa Scaled, I think, may have one.
Think Iowa Scale might
There's
have
half a
some.
dozen vendors making
Yeah,
them.
there's a half a dozen vendors making them, and they're making all kinds of different parts. Yeah, Harry.
I think We're gonna install the one that's in your hand
We're gonna
on this module.
Yep. So the next thing we're gonna do is we're gonna install one of these, two other cables, and two of these straight throughs on this module, and that's the next thing we're gonna do, and tie it down into
The BD20.
BD20.
We'll probably do one of those and one straight through, because that's all we really need. Because the BD20's on the end.
Oh, because the BD20's on the end.
You only need one.
Yep.
We only need two.
Yeah, because one of these products, I'm just gonna, this product is gonna be down here on the end, and it'll be mounted, and so that's gonna give us our one connector on one end. So we'll get this set up, and we'll come back and show you what we did. Okay, so we're almost done with this. We left some things not hooked down just so it'll be easier to see what we did. So remember, we took out that old bus wire because we put in
Accessory bus.
the accessory bus. We put in this other wire instead, so we didn't need the accessory bus wire. We started at this end. We have our BD20. We have our crossover connector, and the BD20 is connected to the crossover connector coming off the little connector here. This is going to get screwed in up here. We need to drill a hole in this rib so we can put this wire through it, but we just unconnect it, slip it through, and put it back in, so that'll be no big deal. This is a straight through cable, and on this end we used a straight through connector that'll get screwed on here because that gives us one crossover, which is this connector at this end, and everything else is straight through, so that we have an odd number of crossovers from, if I can find, from this connection, help me,
Below you,
there,
right
to this connection. From here to here is an odd number of crossovers, and these get mounted. Now on the MSS, what's important to remember is that modules get connected with crossover cables. So we go a crossover cable from here to the connector on the next module, a crossover cable from here to the connector on the next module on that side. So we have an odd number of crossovers inside this module, use crossover cables connected to the next modules. I want to talk real quick about these type of crimp-on connectors. We use them all over the place, especially on our Loconet cables. The black case, or the outside case, should go all the way up into the connector. You can see how it's going up into the connector on this one. If you look at this one's put on bad. I can see the wires in here. That means that this black wire, the stripped part, was too long, because this case should go up inside and there's a crimp that comes down and grabs it, which gives you strain length. On this one, when somebody's messing with this wire, it's pulling on the connection where it's crimped, and that makes it weak, that makes it break, that makes it fail. You want to make sure you get that outside casing all the way up inside the connectors. Chad did a great job. He's got these all the way up inside the connectors, so they're strain release, so when you pull on it, the stress is put on the outside case, not on the wires. So this module is basically done. We need to take and mount these two pieces on either end and put one hole in there, and that's all there is to adding MSS Detection to your module, so that it can be part of the setup, so the signals on other modules will work, so that this one works with the other ones. It's really, I mean, we spent all day doing this module, but we were doing it in pieces, doing it small, adding all of the video. Very little. I mean, really all we added was this black wire, two connections here, and a BD20. Other than that, everything else was basically installed.
And the four bus wires running all the way
Yeah,
through.
we added the bus wires.
Unmolested, so to
Yep.
speak.
The bus wires that go from end to end.
And something you said that just dawned on me, at the end, you're using a crossover cable at each end to connect to the next module on either end, which then gives you odd numbers of crossovers.
Yep. We keep
Crossover cable, crossover fitting, straight cable, straight fitting, crossover cable. 3 crossovers, odd number.
Yep.
Such a magical menu.
And that, all that crossover, what that does is, and having those wires flip-flop, allows this module to spin 180 degrees and still be the same thing. It's that Fremo ends aren't different. Everything is flips and spins, and it doesn't, there isn't an A and a B, and no, correction. We call an end A and we call an end B, so we know which one end is we're talking about, but there is no inside, outside, public side, non-public side. They're universal, they can spin, they can go in any way. And so I think that concludes this video. I hope this helped everybody.
Sure helped
remember,
me.
add the detection bus. It's not very much money, it's not very difficult, and it really helps during setups.